Okay, Makla. Hi, students. Let us study regarding alternating current. And in this chapter, we shall see some important definitions and terminology used commonly in this chapter, alternating current. Fine. Let us see some important terminology. Now, what is called alternating current? Alternating current, the current which changes periodically with the time, is called alternating current. So the current or voltage you can take. EMF or voltage which varies periodically with the time, sinusoidally. That is called alternating current anta ನಾವು ಹೇಳ್ತೇವೆ. Alternating current or alternating voltage. The EMF or current which varies periodically with the time changes its direction periodically. ಒಂದ್ಸಲ ಪಾಸಿಟಿವ್ ಅಲ್ಲಿ ಇರುತ್ತದೆ, ನೆಕ್ಸ್ಟ್ ನೆಗೆಟಿವ್ ಬರ್ತದೆ. It is completely varying, changing. ಯಾವ ತರ? Sinusoidally. So that type of variation is called alternating current. Here the current alters during every half cycle. Change ಆಗ್ತಾನೆ ಇರ್ತದೆ. So it is a current which varies with the time periodically or sinusoidally. That is called alternating current. Now how it is represented? So alternating current graphically is represented shown. Look at the diagram. So this is the variation of alternating current or voltage. Look at the diagram. See, in the there is a positive half cycle and negative half cycle, which varies periodically change ಆಗ್ತಾ ಇದೆ. Okay, up to t/2 second, which is in positive half cycle, which is in positive direction, and remaining half cycle it is in negative direction. So it is changing periodically with the time. So that kind of variation is called alternating current. Students, see, you can see in the case of direct current, steady current, which looks like this. So the steady current which looks like this, nodi ee tara irutte. So this is a representation of DC anta karitare. So this is a representation of AC. Okay na? Fine. So ನಿಮಗೆ AC ಗ್ರಾಫ್ ಅನ್ನ ಬರೀರಿ ಅಂತ ಕೇಳ್ತಾರೆ 1 ಮಾರ್ಕ್ ಅಲ್ಲಿ. You are supposed to write this graph representing current along y-axis and time along x-axis. Look at the variation. The peak value, this is called I0. Peak value of current or peak value of voltage you can take. So I represents current, V represents voltage. Okay na? So this is the representation of AC or AC graph anta ನಾವು ಕರೀತೀವಿ. Now ಹಂಗಿದ್ರೆ what is called one cycle of AC? One cycle of variation. It is a complete variation of AC from 0 to positive maximum, then to negative maximum and back to 0. That means, look at this graph. Look at this. Say starting from 0, it attains maximum. Then negative maximum, then come back to 0. So this kind of variation is called one cycle of variation. Now afterwards it repeats the same cycle. Matte repetition agutte. So it is a complete variation of AC from 0 to positive maximum, then to negative maximum. So this is called positive maximum. So this is called negative maximum. This is 0 again. So starting from 0, end up to 0. So that kind of variation is called one cycle of variation anta karitare. Now let us define some terms again. What is called period of AC? Time taken by AC to complete one cycle of variation. ಅರ್ಥವಾಯ್ತಲ್ಲ? Complete one cycle of variation vary ಆಗಬೇಕು ಅಂದ್ರೆ time ಎಷ್ಟು ತಗೊಳುತ್ತೆ? That is called period of AC. Time taken by an AC. You must represent the word AC. Okay, time taken by an AC to complete one cycle of variation is called period of AC. It is denoted by T, capital T ಅಂತ ಬರಿಬೇಕು. Okay, makla. So in the case of derivation for instantaneous EMF, you nodirtira. So the coil is rotated. The coil is rotated. I thought the time taken for one complete rotation. So ivaga illinda start ಆಯಿತು ಅನ್ಕೊಳ್ಳಿ. ಆಯ್ತಾ? So time taken ನೋಡಿ ಈ rotation ಬರಬೇಕು. ಒಂದು rotation ಬರಬೇಕು ಅಂದ್ರೆ ನೋಡಿ ಹಿಂಗ rotate ಆಗ್ತಾ ಇದೆ, ಹಿಂಗ rotate ಆಗಿ, ಹಿಂಗ rotate ಆಗಿ, ಹಿಂಗ rotate ಆಗಿ ಮತ್ತೆ ಹೋಗಿ ಈ ತರ again ನೋಡಿ ಇಲ್ಲಿ ಬರಬೇಕು. So this is called one complete rotation. The time taken by the coil to go once round for one rotation is called period of AC ಅಂತ ಕರೀಬಹುದು, or time taken by an AC to complete one cycle of variation is called period of AC. Now what is called frequency of AC? just reciprocal of time period. That means the number of cycles of variations of AC completed in 1 second. 1 second ಗೆ ಎಷ್ಟು cycles ಬರುತ್ತೆ? The number of cycles of variation of AC completed in 1 second. So 1 second ಗೆ ಎಷ್ಟು rotation ಆಗುತ್ತೆ ಅಂತ. 1 second ಗೆ ಎಷ್ಟು rotations ಆಗುತ್ತೆ. So the number of variations or the number of cycles of variations of AC completed in 1 second is called frequency of AC ಅಂತ ಕರೀತಾರೆ. It is denoted by F. So by definition, F is equal to 1 by T. Okay, ಮಕ್ಕಳು? You must understand clearly. So ಇದು ನಿಮಗೆ 2 marks ಅಲ್ಲಿ 1 mark ಅಲ್ಲಿ ಕೇಳ್ತಾ ಇರ್ತಾರೆ. So define period of AC, define frequency of AC. Pakka, complete. You must write down clear definition. You must write down AC there. The number of cycles of variations of AC completed in 1 second is called frequency of AC. Aitha? Okay, eradu relation enu? F is equal to 1 by T. That means if you know period, we can find frequency of AC, or if you know frequency of AC, we can find time period. So the other important term is called phase of an AC. Phase. So ಏನಪ್ಪ phase ಅಂದ್ರೆ ಏನು? The fraction of time period of AC that has elapsed since the current last passes its zero value in the positive direction. Fraction of time period. You can see in the diagram, in this diagram, you can see this. ನೋಡಿ ಈ diagram ತಗೊಳ್ಳಿ. ಇಲ್ಲಿಂದ current ಅನ್ಕೊಳ್ಳಿ, y axis current ತಗೊಂಡಿದ್ದೀನಿ. Now look at this variation. So this is 0. So current is starting from 0. Now it attains maximum at a time period of type t by 2. Again becomes 0 at t by 2. Again becomes minus negative maximum at 3t by 4. Again becomes 0. It is called complete t. Okay, fraction of time period. See, the phase of an AC at point A is t by 4. The phase of an AC at point B is t by 2. The phase of an AC at point C is 3t by 4. The phase of an AC at point D is capital T. So like this, you have to understand the phase of an AC. So phase of an AC is the fraction of time period of AC that has lapsed since the current last passes its zero value in the positive direction. So we have to explain in clear. Listen carefully. ಸುಮಾರು ಜನಕ್ಕೆ ಈ ಫೇಸ್ ಅಂದ್ರೆ ಸುಮಾರು ಜನ ಡೌಟ್ ಬರ್ತಿರುತ್ತೆ. ಕ್ಲಿಯರ್ ಕಟ್ ಆಗಿ ಹೇಳ್ಕೊಡ್ತೀನಿ, ಯಾಕಂದ್ರೆ we have to study in detail about these phases in the coming nearby chapter. So explanation, what is this? We have I is equal to I naught sin omega t and V is equal to V naught sin omega t. What is called I naught? Peak value of alternating current. What is called V naught? Peak value of alternating EMF. What is called omega? Angular velocity of coil at a time t. And I and V are called current and voltage at a time t. And omega t is called theta is there. What is called theta? It is an angle between the directions of magnetic field and the normal drawn to the plane of the coil. See, that is called phase angle, theta anta karitara. It represents the position at any instant of time. So here the angle theta andre enu? Angle between the direction of magnetic field and the normal drawn to the plane of the coil. This represents the phase or state of variation of AC. So that is called phase. Okay, ನೀವು ನೋಡಿರ್ತೀರಾ. ಸೊ ನಾವು ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ EMF ನ ಡೆರಿವೇಶನ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಅಲ್ಲಿ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಬರ್ದಿದೆ. ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ನಾರ್ಮಲ್ ಟು ದ ಪ್ಲೇನ್ ಆಫ್ ದಿ ಕಾಯಿಲ್ ಅಂಡ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಥೀಟಾ. ಅಂಡ್ ದಟ್ ಥೀಟಾ ಚೇಂಜಸ್, ಡೆಫಿನೆಟ್ಲಿ ಚೇಂಜ್ ಆಗ್ತಾನೆ ಇರ್ತದೆ. ಆಯ್ತು, ಕಂಟ್ರೀಸ್ ಆಗಿ ಚೇಂಜ್ ಆಗ್ತದೆ. 0 ಡಿಗ್ರಿ ಇರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ 30 ಡಿಗ್ರಿ, 45 ಡಿಗ್ರಿ, 60 ಡಿಗ್ರಿ, 90 ಡಿಗ್ರಿ, 120, ಈ ತರ ಚೇಂಜ್ ಆಗ್ತಾನೆ ಇರ್ತದೆ. ಕಂಟ್ರೀಸ್ ಆಗಿ ಚೇಂಜ್ ಆಗ್ತಿರ್ತದೆ. ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಲ್ಟರ್ನೇಟಿಂಗ್. ಅದು ಚೇಂಜ್ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ದೇರ್ ಇಸ್ ನೋ ಕ್ವಶನ್ ಆಫ್ ಪ್ರೊಡಕ್ಷನ್ ಆಫ್ EMF. ಆ ಚೇಂಜ್ ಆಗ್ಲೇಬೇಕು. ಆ ಚೇಂಜ್ ಆದ್ರೆ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, EMF ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಹಾಗಾಗಿ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಕಾಯಿಲ್ ಚೇಂಜಸ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ, ವಿ ಕ್ಯಾನ್ ಸೇ ದ ಫೇಸ್ ಈಸ್ ಚೇಂಜಿಂಗ್. ಫೇಸ್ ಚೇಂಜ್ ಆಗ್ತಾನೆ ಇರ್ತದೆ, ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇರ್ತದೆ. ಫೇಸ್ ಚೇಂಜ್ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ಸೊ ವಿ ಕಾಂಟ್ ಸೇ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ alternating current or EMF. Okay, now let us represent the phasor diagram. Now ಏನದು? It is a diagram which represents the alternating voltage or current of the same frequency as rotating vectors in the anti-clockwise direction along with proper phase angle between them in the anti-clockwise direction. So now derivations ಮಾಡುವಾಗ next in the case of an AC containing pure resistor, pure inductor, pure capacitance, in case of LCR circuit. So we are supposed to know the phase difference in the case of all those cases. ಹಾಗಾಗಿ ಅದು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂತಂದ್ರೆ first you must understand this. How to represent this? Look at that. Phase difference between voltage and current is more important than their absolute phases. So phase of an AC, phase of voltage or phase of current ಅಂತ ಹೇಳಕ್ಕಿಂತ ಬದಲಿಗೆ phase difference between voltage and current is more important here. For example, in the case of pure resistor, in case of pure inductance, in the case of pure capacitance, in the case of LCR circuit, we have to say whether the voltage and current are in the same phase or out of phase. If they are out of phase, what is the angle between them? What is the phase angle between them? So like that, we have to understand, we have to discuss. So to understand that clearly, let us represent different cases. Case 1, what do you understand by case 1? If voltage and current are in the same phase, how they are represented? See, graphically, they are represented like this. So this is a representation graphically, voltage and current. What do you mean by that? Same phase means what? If voltage is 0, current also 0. If voltage attains maximum, current also attains maximum. If voltage again becomes negative maximum, at the same time, current also becomes negative maximum. See, both of them changes simultaneously. Simultaneously change ಆಗ್ತಿರುತ್ತೆ. Both of them attains 0. Both of them attains negative maximum. Both of them attains positive maximum simultaneously. So that kind of variation we call as same phase. So here voltage and current are in the same phase. Graphically ಅದನ್ನ ಆ ತರ ಬರ್ದಿದೀವಿ. So vectorial ಆಗಿ ಅದನ್ನ ಹೆಂಗ್ ಬರಿಬಹುದು ಅಂತಂದ್ರೆ look at this. This is a vectorial representation of voltage and current. ಅಥವಾ ಅದನ್ನ ಹಿಂಗೂ ಬರಿಬಹುದು. Look at the graph. ಇದು ಕೂಡ ಹಿಂಗೂ ಕೂಡ ಬರಿಬಹುದು. Voltage and current. ನೋಡಿ ಆ voltage V ಅನ್ನ green line ಅಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ, current I ಅನ್ನ blue line ಬರ್ದಿದ್ದೀನಿ. So both of them are in the same line or parallel to each other. So aವಾಗ we can say voltage and current are in the same phase, or we can say voltage and current have 0 phase difference, or the phase difference between voltage and current is 0, like this. Okay, makla? So this is a representation of phase in the case of two quantities, voltage and current, which are in the same phase. Case 2, suppose if voltage and current are out of phase by 180 degree. They are out of phase by 180 degree. Look at the graphically and vectorially. This is a vectorial representation. See, voltage ee kade itre, current ee kade ide. So their phase difference is 180 degree. They are out of phase by 180 degree or pi radian. Aita matte case 3 is this. If voltage and current have the phase difference of 90 degree or pi by 2 radian, then how they are represented? Look at the graph. In this graph, we can say voltage is a leading current, or current lags voltage by pi by 2 radian, or we can say it is 90 degree. ನೋಡಿ diagram ಅಲ್ಲಿ ನೋಡ್ತಾ graph ಅಲ್ಲಿ ನೋಡ್ತಾ ಇರಿ, voltage ಮುಂದೆ ಇದೆ, current ಹಿಂದೆ ಇದೆ. Voltage is a leading current, or current is a lagging voltage. Voltage ಮುಂದೆ ಇದೆ, current ಹಿಂದೆ ಇದೆ, ಅಥವಾ current ಹಿಂದೆ ಇದೆ, voltage ಮುಂದೆ ಇದೆ. Voltage leads current by pi by 2, or current lags voltage by pi by 2. Both means the same. Hangidre adana how we are representing vectorially. Look at this. Vectorially ee tara baribodu. Nodi in the first diagram, this is the first diagram where voltage leads current by 90 degree or pi by 2 radian. Okay, idanne keloru current lags voltage by pi by 2 radian anta karitare. At the same time, second graph nodi, second graph, right side of the screen nodi, look at that. Here I can say current leads voltage by 90 degree. Current leads voltage by 90 degree or pi by 2 radian. Or voltage lags current andru anbodu. So ನಾನು ಯಾಕೆ ಹೇಳ್ತೇನೆ ಅಂತಂದ್ರೆ vectorial ಆಗಿ representation ಕಲ್ತ್ಕೋಬೇಕು ನಾವು. ಆಯ್ತಾ? This is a representation of vectorial representation of phase lead or phase lag. Okay. ಅಥವಾ I can say like this. ನೋಡಿ ಇದನ್ನ ಹಿಂಗೋ ಬರೀಬಹುದು. Look at the graph. In the first graph, in the left side of the screen, we can see voltage along y-axis, current along x-axis. Voltage ಮೇಲ್ಗಡೆ ತೋರಿಸಿದ್ದೀನಿ. It is in upward direction. Voltage leads current. voltage leads current by 90 degree or pi by 2 radian. Athwa in the right side nodi, here it is called current lags voltage by 90 degree or 9 pi by 2 radian. Ingu bekaru ನಾವು ವೆಕ್ಟೋರಿಯಲ್ ಆಗಿ ಬರಿಬಹುದು ಮಕ್ಕಳ. ಆಯ್ತಾ, ಇದನ್ನ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಗೊತ್ಕೊಳ್ಳಿ, ತಿಳ್ಕೊಳ್ಳಿ. ಸೊ ವೋಲ್ಟೇಜ್ ಲೀಡಿಂಗ್ ಕರೆಂಟ್ ಅಂದ್ರೆ ಹಿಂಗ್ ಬರಿಬೇಕು, ಕರೆಂಟ್ ಲ್ಯಾಗ್ಸ್ ವೋಲ್ಟೇಜ್ ಅಂದ್ರೆ ಹಿಂಗ್ ಬರಿಬೇಕು. ಲೀಡಿಂಗ್ ಅಂದ್ರೆ ಮೇಲ್ಗಡೆ ತೋರಿಸಿ, ಲ್ಯಾಗಿಂಗ್ ಅಂದ್ರೆ ಡೌನ್ವರ್ಡ್ ತೋರಿಸಿ. ಸೊ ವೋಲ್ಟೇಜ್ ನೋಡಿ, ಇನ್ ದ ಫಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ ವೋಲ್ಟೇಜ್ ಲೀಡ್ಸ್ ಕರೆಂಟ್ ಅಂದ್ರೂ ಒಂದೇ, ಕರೆಂಟ್ ಲ್ಯಾಗ್ಸ್ ವೋಲ್ಟೇಜ್ ಅಂದ್ರೂ ಒಂದೇ. ಬಟ್ ಇನ್ ಸೆಕೆಂಡ್ ಡಯಾಗ್ರಾಮ್ current lags voltage by 90 degree or voltage leads current by 90 degree. Both means same. ಹೆಂಗ್ ಬೇಕಾದ್ರೂ ನಾವು ಬರ್ಕೋಬಹುದು. ಬಟ್ ನಾರ್ಮಲಿ ಲೀಡಿಂಗ್ ಅನ್ನ ಮೇಲ್ಗಡೆ ತೋರಿಸ್ತೀವಿ, ಲ್ಯಾಗಿಂಗ್ ಅನ್ನ ಡೌನ್ವರ್ಡ್ ತೋರಿಸ್ತೀವಿ ಅಷ್ಟೇ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡುವಾಗ. ಓಕೆ ಮಕ್ಕಳ, ನಾವು ಲೆಟ್ ಅಸ್ ಸಿ ಸಮ್ ಇಂಪಾರ್ಟೆಂಟ್ ಟರ್ಮ್ಸ್ ಯೂಸ್ಡ್ ಇನ್ ಎಸಿ. ಇಲ್ಲಿ ನಿಮಗೆ ಈಕ್ವೇಶನ್ಸ್ ಕೇಳಬಹುದು, ಸಮ್ ಡೆಫಿನೇಷನ್ಸ್ ಅನ್ನ ಕೇಳಬಹುದು. ಇದರಲ್ಲಿ ಏನದು ಪಾಯಿಂಟ್ ನಂಬರ್ 1, instantaneous value of current or voltage. Instantaneous. And what do you mean by instantaneous? The value of AC at any instant of time. It is a value of alternating current or voltage at any instant of time. That is called instantaneous value of AC and karitar. Equation in kodtini, V is equal to I is equal to I naught sin omega t and V is equal to V naught sin omega t. Those equations represents the instantaneous value of AC. Now, what is called I naught and V naught? They are representing peak value of current and voltage. Okay, now ನಿಮಗೆ ಅಕಸ್ಮಾತ್ ನಿಮಗೆ 1 ಮಾರ್ಕ್ ಅಲ್ಲಿ 2 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ ಕೇಳಿದಾಗ ಈ ಡೆಫಿನೇಷನ್ ಬರೀಬೇಕು. ಸೊ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ವ್ಯಾಲ್ಯೂನ ಡಿಫೈನ್ ಮಾಡಿ ಅಂತಂದ್ರೆ, ಇಟ್ ಇಸ್ ಅ ವ್ಯಾಲ್ಯೂ ಆಫ್ AC or alternating current or voltage at a given instant of time. ಆಯ್ತಾ? So how they are represented? I is equal to I naught sin omega t and V is equal to V naught sin omega t. Here I and V ಅಂತ ಕೊಟ್ಟಿದ್ದೀನಲ್ಲ, that is called instantaneous value of AC ಅಂತ ಕರೀತಾರೆ. Then what is called peak value of AC? Peak value of AC ಅಂದ್ರೂ ಒಂದೇ or amplitude of AC ಅಂದ್ರೂ ಒಂದೇ. ಮಕ್ಕಳ, it is the maximum value of AC reached, attained ಅಂದ್ರೂ ಒಂದೇ, reached ಅಂದ್ರೂ ಒಂದೇ, during each half cycle of AC. It is a maximum value of AC reached or attained during each half cycle of AC. They are represented as I naught and V naught. So I naught V naught represents the peak value of AC. So in the graph you can see, nodi illi graph nimge toristini nodru, I mean this one. Okay, so in this graph nodi, this represents the peak value of current. Nodi, this is called peak value of current. This also called peak value of current, peak value of AC, or it may be a current or voltage. Okay, now so that is called peak value or amplitude of AC. So this is called amplitude. Okay, this is called peak value. This is called peak value. So what is called peak value? The maximum value of AC attained during each half cycle. Attained andru onde, reached andru onde. Okay, now fine. So now what is called mean value of AC? Mean value of AC is also called average value of AC. What do you mean by that? It is a mean of all the instantaneous values of AC taken over in each half cycle. Important term idu, in each half cycle. We take the mean value, we take the average value only for half cycle, not for complete cycle. Because mean value or average value of AC over complete cycle is 0. ಅರ್ಥವಾಯ್ತಲ್ಲ, ಕೇಳ್ತಾ ಇರ್ತಾರ, ವಾಟ್ ಇಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಮೀನ್ ವ್ಯಾಲ್ಯೂ or average value of AC over complete cycle ಅಂತಂದ್ರೆ it is 0. ಅದಕ್ಕೆ we define mean value only for half cycle. So it is a mean of all instantaneous value of AC taken over in each half cycle. How it is given by? It is given by, look at that, IM is equal to I average is equal to 2 by pi I naught. So there is no derivation for you, just write down directly. So I average 2 by pi I naught and V average 2 by pi V naught. Now what is called I naught? Peak value of current. What is called V naught? Peak value of voltage. So here we can represent IM or I average. IM andru onde, I average andru onde. Okay, nimage ಅಕಸ್ಮಾತ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾ ಇರ್ತಾರೆ, write the relation between average value and peak value of current ಅಂತ ಕೊಟ್ಟಾಗ ಆ ಮೇಲ್ಗಡೆ ಈಕ್ವೇಶನ್ ಇದನ್ನ ಬರಿಬೇಕು. So write the relation between peak value of voltage and peak value of mean value of voltage and peak value of voltage andre Vm is equal to 2 by pi V naught. ನಾವು ಕರೆಂಟ್ ಅಂತ ಕೊಟ್ಟಾಗ ಮೇಲ್ಗಡೆ ಈಕ್ವೇಶನ್ ಬರೀರಿ, ವೋಲ್ಟೇಜ್ ಅಂತ ಕೊಟ್ಟಾಗ ಈ ಈಕ್ವೇಶನ್ ಬರೀರಿ. ಸೊ ಅವಾಗ ಟರ್ಮ್ಸ್ ಕೇಳಬಹುದು, ಬರೀರಿ. I naught and V naught are called peak value of current and voltage. So remember another important point, mean value of AC over complete cycle is 0. ಕೇಳ್ತಾ ಇರ್ತಾರೆ, ವಾಟ್ ಈಸ್ ದ ಮೀನ್ ವ್ಯಾಲ್ಯೂ, ವಾಟ್ ಈಸ್ ದ ಆವರೇಜ್ ವ್ಯಾಲ್ಯೂ. ಆವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಅಂದ್ರೂ ಒಂದೇ, ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ AC ಅಂದ್ರೂ ಒಂದೇ. ಸೊ ಕಂಪ್ಲೀಟ್ ಸೈಕಲ್ಗೆ ಇಟ್ ಈಸ್ 0. Okay, done. We shall see another important definition, RMS value of AC. Now, what is called RMS value? So, there are different definitions for RMS value of AC. One of the definition is, it is a square root of mean of squares of all instantaneous values of AC taken over a complete cycle. So, one mark define RMS value of AC. It is the square root of mean of squares of all instantaneous values of AC taken over a complete cycle. You must write down full sentence. Purtiyag baradane you will get mark. Otherwise, you will not get any mark. That is the definition. As it is, baribek now. So, what is the relation between IRMS and peak value? Nodi kottidini. IRMS is equal to I naught by root 2 and VRMS is equal to V naught by root 2. No derivation for you. Just mention of equations. IRMS is equal to I naught by root 2 and VRMS is equal to V naught by root 2. What is called I naught? Peak value of current. What is called V naught? Peak value of voltage. What is called IRMS? RMS value of current. Or VRMS andre RMS value of voltage. ನಿಮಗೆ ರಿಲೇಷನ್ ಕೇಳ್ತಾರೆ, write the relation between RMS value and peak value of current andre IRMS is equal to I naught by root 2 ಬರೀರಿ. Write the relation between RMS value of voltage and peak value of voltage andre VRMS is equal to V naught by root 2 ಬರ್ಕೊಳ್ಳಿ. ಏನು ಮಕ್ಕಳ? So this is a very important question for PU board exams for 1 mark and 2 mark questions. Even for solving problems also we used to take these equations. Sometimes it is asked IRMS value, RMS, find the value of current in circuit. We use that equation. Or find the peak value of current. So peak value baribodalva. So from those equations I can rearrange. What is called I naught? I naught is equal to root 2 into IRMS. P naught is equal to root 2 into VRMS. See, peak value is more than IRMS by root 2 times. V naught is greater than VRMS by root 2 times. Alva, nimage IRMS kottidre I naught madabodu. So that is the equation which we are going to use while solving the problems. Okay, now it is given like this. Write the relation between mean value and RMS value of AC. ನಿಮಗೆ ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಪೀಕ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದೀನಿ, RMS ವ್ಯಾಲ್ಯೂ ಪೀಕ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದೀನಿ. ಇವಾಗ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಅಂಡ್ RMS ವ್ಯಾಲ್ಯೂ ಕೊಡ್ತಾರೆ. ಸೊ ಮಕ್ಕಳ ತಿಳ್ಕೊಳ್ಳಿ, ಸುಮಾರು ಜನ ಸ್ಟೂಡೆಂಟ್ಸ್ ಏನ್ ಮಾಡ್ತಾರೆ, they try to remember, they try to memorize the equations. It leads to some confusion. So better you remember one equation and rearrange according to the question. ಅಂದ್ರೆ ಇವಾಗ ನಮಗೆ ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಅಂಡ್ RMS ವ್ಯಾಲ್ಯೂಗೆ ಡೈರೆಕ್ಟ್ ರಿಲೇಷನ್ ಕೊಟ್ಟಿಲ್ಲ, ಬಟ್ ವಿ ನೋ ದಿ ಇಂಡಿವಿಜುವಲ್ ಈಕ್ವೇಷನ್ಸ್. ಏನದು? ವಿ ಹ್ಯಾವ್ ದಿಸ್ IM is equal to 2 by pi I naught. You remember this equation, that's it. Also you remember IRMS is equal to I naught by root 2. ಇವೆಲ್ಲ ಮೇಲ್ಗಡೆ ಈಕ್ವೇಷನ್ಸ್ ಅನ್ನು ಹೇಳಿದ್ದೇನೆ. So IM is equal to 2 by pi I naught, IRMS is equal to I naught by root 2. ಓಕೆನಾ? ಇವಾಗ ಈಕ್ವೇಷನ್ 1 ಬರ್ಕೊಳ್ಳಿ ಮೇಲಿದ್ದು. Now in the second equation rearrange for I naught. I naught is equal to root 2 into IRMS. Now substitute I naught in the above equation 1. Avaga IM is equal to 2 by pi hangge barkoli. Substitute for I naught. Root 2 into IRMS. Root 2 into IRMS. That's it. So we have IM is equal to 2 by pi root 2. ಅಥವಾ 2 root 2 by pi ಅಂತ ಬೇಕಾದ್ರೂ ಬರ್ಕೋಬಹುದು. See, this is 2 root 2 by pi into IRMS. ಈ ತರ ಬೇಕಾದ್ರೂ ಬರೀಬಹುದು. ಸೊ ನಿಮ್ಗೆ ಅಕಸ್ಮಾತ್ ರಿಲೇಷನ್ ಕೇಳ್ತಾರೆ, ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಅಂಡ್ RMS ವ್ಯಾಲ್ಯೂ ಕೇಳ್ತಾರೆ ಅಂತಂದ್ರೆ ಇದನ್ನ ಬರೀಬೇಕಾಗುತ್ತೆ. ಸೊ IM is equal to 2 root 2 by pi into IRMS. ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ ಮಕ್ಕಳ. ಅದಕ್ಕೆ ದಟ್ಸ್ ವಾಟ್ ಐ ಆಮ್ ಟೆಲಿಂಗ್, ಬೆಟರ್ ಯು ರಿಮೆಂಬರ್ ದೀಸ್ ಈಕ್ವೇಷನ್ಸ್. ಒನ್ ಈಕ್ವೇಷನ್ ನಾವು ಕೇಳ್ಕೊಳ್ಳಿ, IM is equal to 2 by pi I naught always, ಅಥವಾ IRMS is equal to I naught by root 2. These are the two very important equations. By using these equations you rearrange. How? ನೋಡಿ, ಇವಾಗ ಈಕ್ವೇಷನ್ 1 ಬರ್ಕೊಳ್ಳಿ, ಈಕ್ವೇಷನ್ 2 ಸೆಕೆಂಡ್ ಈಕ್ವೇಷನ್ ನೋಡಿ, IRMS equal to I naught by root 2. ಅದರಿಂದ ಸಪರೇಟ್ ಫಾರ್ I naught equals root 2 into IRMS. Now substitute I naught in equation 1. Avaga Im is equal to 2 by pi root 2 IRMS. So this is the relation connecting mean value and RMS value. So RMS value kotre mean value ಮಾಡಬಹುದು, mean value kotre RMS value ಮಾಡಬಹುದು. Rearrange ಮಾಡ್ಕೊಳ್ಳಿ. ಇವಾಗ 2 marks ಲೆಕ್ಕ ಕೇಳಬಹುದು. RMS value of current is so much ampere, find the mean value of current. Or mean value of current is so much ampere, find the value of IRMS. Rearrange ಮಾಡ್ಕೊಳ್ಳಿ. ಆಯ್ತಾ? So for example, ಇವಾಗ ಇದನ್ನ ಹಿಂಗೂ ಬರಿಬೋದಲ್ಲ. Look at this. So IRMS ಬೇಕು ಅನ್ಕೊಳ್ಳಿ. See, IRMS is equal to IRMS ಹೆಂಗ್ ಬರಿಬೋದು? Pi divided by 2 root 2 into IM. ನೋಡಿ ಇವಾಗ IRMS is equal to pi by 2 root 2 into IM. ನೋಡಿ, that is the equation. ಅಥವಾ ಎರಡು ಒಂದೇ. So mean value of current ಕೊಟ್ರೆ RMS value ಮಾಡಬಹುದು, RMS value ಕೊಟ್ರೆ mean value ಮಾಡಬಹುದು. So 2 marks ಅಲ್ಲಿ ಕೇಳಬಹುದು, ಇಲ್ಲ 5 marks ಅಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ ಕೇಳುವಂತದ್ದು ಅಲ್ವಾ. At the same time, now what is called mean value of voltage? Vm is equal to 2 by pi V naught, that we know well. VRMS is equal to V naught by root 2. Already ಮೇಲ್ಗಡೆ equations use ಮಾಡ್ತಾ ಇದೀನಿ. Now which implies V naught is equal to how much? Root 2 into VRMS. V naught is equal to root 2 into VRMS. Substitute that in the above equation 2. ನೋಡಿ, equation 2 implies Vm is equal to 2 by pi. Substitute for V naught, root 2 into VRMS. Okay, makla? So this is very important. ನೋಡಿ ಇವಾಗ VRMS ಕೊಟ್ರೆ VM ಮಾಡಬಹುದು, VM ಕೊಟ್ರೆ VRMS ಮಾಡಬಹುದು. ಇದು rearrange ಮಾಡ್ಕೊಳ್ಳಿ. For example, ನನಗೆ if I want VRMS ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ನೋಡಿ VRMS ಗೆ ಬರಿಬಹುದು pi divided by 2 root 2 into VM. Look at that. So VRMS is equal to pi by 2 root 2 into VM. That's it. Okay. So ಇದನ್ನು ಕೂಡ ಅಷ್ಟೇ ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇರ್ತೀವಿ. ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೋಬಾರದು. ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ ಯಾವತ್ತೂ ಕೂಡ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. Don't go to memorize everything. You must understand and better keep in mind. Important note is there. ಏನದು? Just I have written some important equations. But ಅದು ಇವಷ್ಟು ತಿಳಿದ್ನಲ್ಲ. IRMS is equal to I naught by root 2. VRMS is equal to V naught by root 2. IM is equal to 2 by pi I naught. VM is equal to 2 by pi V naught. So remember these equations. ಇವಾಗ ಈಕ್ವೇಶನ್ಸ್ ಗೊತ್ತಿದ್ರೆ ನಾವು ಲೆಕ್ಕಗಳು ಸಾಲ್ವ್ ಮಾಡಬಹುದು, ನ್ಯೂಮರಿಕಲ್ಸ್ ಸಾಲ್ವ್ ಮಾಡಬಹುದು, 2 marks ಅಲ್ಲಿ ಆನ್ಸರ್ ಮಾಡಬಹುದು, ರಿಲೇಷನ್ ಬರೀರಿ ಅಂತಂದ್ರೆ ಬರೀಬಹುದು. ಅರ್ಥವಾಯ್ತಲ್ಲ? ಸೊ ಲೆಕ್ಕಗಳು ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಇಟ್ ಮೇ ಬಿ ಆಸ್ಕ್ಡ್ ಫಾರ್ 2 mark ಕ್ವಶನ್ ನ್ಯೂಮರಿಕಲ್, 3 mark ನ್ಯೂಮರಿಕಲ್ ಆರ್ 5 marks ಅಲ್ಲಿ ಸಬ್ ಪಾಯಿಂಟ್ ಕೇಳಬಹುದು. ಓಕೆ ಮಕ್ಕಳ? ಸೊ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟುಡ್ ದಿಸ್ ಬೇಸಿಕ್ ಟರ್ಮಿನಾಲಜಿ ಯೂಸ್ಡ್ ಇನ್ AC. So better you I hope you understood these concepts. Okay. In the next video we shall see how the voltage and current changes in phase in case of an AC circuit containing pure resistance, pure inductance, pure capacitance, and in the LCR circuit. So those are the important equations, derivations are there. 3 mark questions may be asked for that. Even 5 mark question also will be there. Okay. Right. I will stop this. Okay. Thank you very much for observing this video. So, ನೀವು next video na shortly ನೋಡ್ತೀರಾ. So till then, take care. Bye.